This is the supplemental lecture video number 6 for the last week of this course. Today, the topics are, first of all, exponential and logarithmic functions. And then next we have the section called converting units. They are both the skills needed for the corresponding Math 146 and then the other projects you have in the college or in the future. So it's useful to learn them. All right. So first of all, you're going to work on the logarithmic function, and then you'll see the equation with log, with base A, and the result value B that equals to X. And then, right, that equation is equivalent to A to the X equals B. So this is the review of the log function, and then you have to know that A is called the base value, and then the X is called the exponent, which is another name for power. And then B is called the resultant value. So for example, right, 10 to the 2 equals to 100. So log of the base 10, 100 gives you 2. So first of all, the log function is made up by human. If you don't understand it completely, that's what I can tell you. It's created by human to calculate a power directly. So when you plug in log function, if you have a scientific calculator, then you can plug a log function with the info entered, then you'll get exactly what power is on that example. That's one reason we use logarithmic function, right? So this expression here is logarithmic, this one, and then that one is called exponential form, right? Logarithmic form of equation and exponential form of equations, and then both of them are related in this way. All right. We'll dig into these two info more later on, but first of all, let's see the examples we have and let's understand how to solve them accordingly. All right, solve for X. All right, so if you see this type of question, then you have to figure out a way to solve for X. And then we're going to apply something called the like base property. Because first of all, you have the base as 5 and 25 on each side of the equation. They're different and they don't match, right? So the way to handle this type of problem is to normally turn one of the values into something with the same base, like 25 equals to 5 squared. That makes sense because 25 equals to 5 times 5, right? So that's why we have 5 to the 2. And then if you apply 5 to the 2 on that right-hand side, what you get is 5 to the 4x minus 4 equals 5 to the 2 with the power 3x plus 2. And then, yes, the powers can be multiplied in this way. So you will have 5 to the 2 times 3x plus 2, and then you'll expand that term later on. All right, the condition is met. Right, the reason we're doing this is because if you have the same base for the equation, then the powers will equal, and that is why. So I'll use the red pen to show you that now you can equate two powers from both sides of the equation. Then this turns into the algebra problem for you to find the final answer. Expand the right-hand side, then you have 4x minus 4 equals 6x plus 4. And then if you take off 4x on both sides, then you have, and you also take off 4 on both sides of the equation, and then you add both lines, then you get -4 plus -4, which gives you -8, right? 6x plus -4x, the like terms gives you 2x. So divide that finalized equation. No, you divide that equation by 2, then you'll get x equals to -4. That's the answer. Right. And next, use the like-based property and exponents to solve the equations. And luckily, sometimes you'll have the statement in this way. And that means, hey, you do have to apply this property to find an answer. So let's see how to deal with this tricky one. We have two bases. We have 625 and another one is 1/25. And they don't match at all. So what should we do? All right, so first of all, if you recall, this, the 625 can be factored to smaller information, then you will see that 625 equals to 25 times something. It's 25 times 25, and then we can prove it this way. If you try the multiplication on that number, then you'll have 125 plus 50, 500, and then you'll get 625 for sure. So yes, so that means 625 equals to 25 squared. All right, now we're getting somewhere because now we have 25 squared x. Remember, we have another exponent called x, which can be multiplied by 2, and that equals to 1/25. All right, then we got to figure out a way to deal with the right-hand side. But if you recall the inversion property, then you can see that 1/a value will equals to the value to the -1. Right. So let's recall it. 10 to the -1 equals to 1/10. You invert the 10 and you get 1/10, right? And then 100 to the -2. That's another example. 100 to the -2 will gives you 1/100 squared. Because the way to invert that inverse is to flip the sign on the exponent and then place 100 on the denominator. So essentially, we can say that that's one. For the previous one, we can also say that we have 1/10 to the 1, which is the same as 1/10. So that's how you invert the fraction. So that inversion shows you info as 25 to the -1. So on the next step, so that is step 1 and that is step 2. In step 3, we have 25 to the 2x. Simplify the left-hand side, and then the right-hand side will give you 25 to the -1. Okay, now we can solve the problem because we have gotten the like basis on both sides. Yes, that is the condition for you to equate the power. 2x equals to -1. Divide the equation by 2. X equals to -1/2. Problem solved. All right, next example number 3. Use the like-base property and exponents to solve the equation for n. Right. Now they're being more and more specific, and then now it is obvious that we are finding n. What is our n? All right, so we have the equation given, so we can use the same trick. 1/3 equals to 1/3 to the 1, right? So if you invert that fraction, then you'll have 3 to the -1, right? And on the other hand, we have 243 on the right, but let me take care of the left-hand side. 3 to the 1 and equals 243. So that is step 1. And then that is step 2. All right, we have the base called 3 on the left, and then it's intuitive for us to turn 243 into something with the base 3. So let's think about it. If you have 243, then that equals to 3 times 3 times 3 times 3 times 3. So if you work on the factoring, then that's what you'll find. Right. If you multiply the 3 by 5 times, then you'll have 3 to the 5. So yes, that is the power for the base 3. So what do you get next? You'll have 3 to the -n, because -1 times n gives you -n, right? 3 to the -n equals 3 to the 5. All right. That's how I figure out the same base. So that -n equals to 5. You flip the sign, then problem solved. N equals to -5. That is the answer. All right, so we have practiced enough on the like-base property. Now let's go over the log example. So now you have something that looks a bit scary. All right, let's think about how to handle it. All right, you have log base 4 of 1/256 equals to x. So that matches the equation setup we have from before. We have base A of b equals x. So a goal, when you evaluate the log, then that means you're finding the x. So remember, whenever you have a log question, you can turn that form into the exponential form so that you have a to the x equals b. Because sometimes if you don't have a calculator, it'll be tricky to figure that out. And then some calculator don't even have a base function for you to figure out a value. So sometimes we have to do it manually. And then in this example, a equals to 4. That is the base of the log, and b equals to 1/256. So what we are having is 4 to the x equals 1/256. I'm matching this equation to get that. Make sense? All right, now this question looks similar to the previous one. All right, now I'll test you in this way. What should we do next? For finding x, what should we do next? Yes, you will use the like-based property, right? And then if you recall that 256 can be factored, then that will be 4 times 4 times 4 times 4. The reason we choose 4 as a factor is because we have the base of 4 and we want to match thing. And then in case you didn't know how to factorize a given number, that I can show you. The long division shows that 256 divided by 4 gives you 64. And then if you do that with the number 4, then that gives you 16. And then 16 divided by 4 gives you 4. So you have 4 times 4 times 4 times 4. Right. So I didn't show you that method for factoring the value, but I'm showing you right here in case you were lost. I hope that helps. Okay, so we have this, where we have 1 over 256, which, and then 256 equals to 4 to the 4. So that means we have 1 over 4 to the 4, right? Okay, then invert the right-hand side fraction. And then what do we get? 1 over 4 to the 4 turns into 4 to the negative 4. Right, it is mathematically correct. And now we know that we flip the sign for the exponent and then turn it denominator into a result like that. All right. We have the same base again. So x equals to negative 4. That's the answer. That is the power we solved from the log function. All right, let's go over something trickier. Solve for x. Give answer as a reduced and simplified fraction. All right, noted. If needed. So let's see. Log base 2, then remember the exponential form of that equation will be 2 to the 5 equals to 4x minus 5. Why? Because a equals to 2. Let me actually do it other way around so that I can show you a good example. Right. When you see a log equation, then we can tell that the base a equals to 2. And then the x, which is different from the x we have, but we can include that later. But we do know that b equals to 4x minus 5. So that we have a and b given for us to craft the exponential form of this equation. That will be 2 to the 5 equals to 4x minus 5. Right, I know it can be confusing because we have the variable x showing up in that equation. So I'm going to make up the x with that form to show you that the value we have there equals to 5 for matching this equation. A to the capital X equals B. I'm making up a capital X because we have a small x in part of the question. So we shouldn't mix up the units. We shouldn't mix up the symbols in this way. All right, now this becomes a simple algebra problem. And we don't apply the like-based property because there's no way for you to turn this into something to the exponent, right? So this question will be easier than expected. 2 to the 5 equals 32. 32 equals 4x minus 5. All right, now we do algebra again. add 5s on both sides, so you have 37 equals to 4. All right, divide the equation by 4. Then problem solved. 4s are divided out. We have practiced enough on the algebra, so you get a simplified fraction. And that's exactly what the answer should look like. A reduced fraction, 37 over 4. We can't reduce that anymore because 37 is a prime. Okay. All right, so these are the examples from 6.1. And then for section 6.2, we are converting units. All right. So why are we converting units? Because we want to turn the unit of a dimension into something we are more familiar with. So for example, convert 1.5. Oh no, do I skip one? All right. Yes, convert 5 inches to centimeter. Round your answer to the nearest tenths. All right, I'll tell you what. There's a conversion factor for us to memorize. 1 inch. So 1 inch equals to 2.54 centimeter. And centimeter is the common unit you see on the ruler, right? We have an inch version, which is not that common. So that gives us a good reason to convert the inches to centimeter. All right. So let me show you how to convert a unit. So make sure you watch the video first, and then the review here will be better. So if you have 5 inches given, and then we can use the symbol IN for the unit. The method we will apply is called the fraction method. And let me show you. The fraction is being set up in this way. We have 1 inch equals to 2.54 centimeters. So if we divide the equation by 1 inch, then that fraction will turn into 1. So you'll have 1 equals to 2.54 centimeter over 1 inch. Okay, right. So that means that fraction has the numerator and denominator in the same dimension now. And then that fraction equals 1. And you can flip these two info and get 1 equals to 1 inch over 2.54, because we have the same value over same value in the same dimension. So that these two numbers will divide out, it gets you 1. So we got to make a choice of the fraction we plug in. And I'll tell you what, I'm choosing 2.54 over 1 inch. And why do we do that? Yes, there's always a reason we do math in a way. We're doing this to divide out the inch unit, because we want to eliminate the inch unit to get the centimeter unit as a part of our answer. That's why. And then the answer will be 12.7 centimeter. All right. So this is the idea of unit conversion. And then we want the answer to the nearest 10, which is like that, because when you have that first decimal place, then that is called a tens place. So that is the right format of the answer. So if you have something like 12.70, if you put it down like that, then that's not the right format of the answer, because you are not allowed to have more than 1 decimal places on your answer. So this is wrong, right? If you follow the rules and know the language of math, then you can tell that, hey, based on the requirement, the answer only has one decimal place. All right, before I move on, I will show you a wrong way of doing this question, and I'll show you why we shouldn't do so. So let's say that, hey, professor, this is a fraction method for us to take care of the unit. So why don't I use another version? Why don't I use 1 inch over 2.54 centimeter? All right, I'll tell you what. I'll test your knowledge. Pause the video and think about it. Why is so? Again, that is incorrect. Why? Think about it. All right. The reason is that if you do this, then you end up getting 5 over 2.54, and then you will end up having a more complicated unit set. Inch times inch gives you inch square over centimeter, right? You do not convert a unit, but instead you turn that unit set more, you make the unit set more complicated, which is not sensical at all, because we want to make sure the desired unit remains. So that is the reason we have that right form of the fraction. Okay, think about it. Then we can move on, right? Miles, convert 1.5 miles to centimeters. All right, so another useful conversion factor for us to note. 1 mile equals to 1,609 meter. M stands for meter. And then another saying we have is 1 meter equals to 100 centimeter. I'll show you how this works. We have 1 mile, 1.5 mile given. So again, we're turning mile into centimeter. So let's do it. The first fraction will be set by that info, 1,609 meter over 1 mile. And why do we do that? Because we want to divide out the mile unit so that the meter remains. But the meter unit is not the final unit we want. So in this example, we are multiplying the fraction again. We're multiplying another fraction to take care of the meter unit. 100 centimeter over 1 meter. Why? Because meters can be divided out so that a centimeter remains. So if you plug things into calculators and you're allowed to do so, then you'll have this info in centimeter. And then the final answer will be a huge number, which is 241,350 centimeter. All right, they don't have the rules about the answer format, so we can leave it as an integer, which is totally fine. And problem solved. Let me put a star on each box of the answer. All right, now we have example 8. Let's go over another different unit. We have something squared, the length unit squared. So feet is the length unit. All right, so we do have a specific conversion factor given because that means you don't have to memorize it. 1 meter equals 3.28 feet. All right. Our goal is to convert 12.4 feet squared into square meters. So in case you didn't know, square meter means m to the 2. And that also equals to m times n. We're multiplying m's twice. And then, right, this is the unit of area. And then let me give you an example. So let's say that you purchase a furniture And then the dimension of the length times width will be 3m times 2m. That's the info you see on the product. And then the dimension will look something like that for your table, for example. You have the length of 3m, the width of 2m. And then when you calculate the area, then that sum, the result will be 2m squared. So m squared is the area unit for any object. And the shaded area is exactly 6m squared. Great. So we may go, hey, we have the unit feet squared given. So all we need to do is to plug in the fraction as 1 meter over 3.28 feet, right? All right, that problem solved. All right, I'll give you a warning. This is not correct. Why? Okay, think about it again, and we'll come back to it. All right, the unit is correct. That setting is incorrect because we did not square the fraction. We have to, that was a common mistake I saw from a student's paper. And that's why I want to give you a visual aid in this way, right? We're not supposed to do that. Why? Because we have to square all the units to match the feet square unit. And this is how it works. 12.4 feet squared. So when you apply the power of 2 on the entire fraction, that everything will be squared, okay? Including the values and the units, everything, every single part of the fraction will be squared. And then that's when you're allowed to divide out the feet square so that the meter square remains. Okay, so let me erase the wrong symbol here. That should be a multiplication sign. There you go. All right, so we have numerator 1 to the 2, which is essentially 1. So when we combine two fractions for calculation, then that'll be 12.4 over 3.28 squared with the unit meter squared. All right, then plug things into the calculator, then you will get 1.15, which is not the format we want because we need to round answer to 1 decimal place. So if we have a specific instruction, then we have to convert, we have to make sure the format is right. So the answer will be 1.2 meters squared. That is your answer. .2 meters squared for the room area. That's quite small. All right, last but not least, another practice on the unit conversion. The acceleration of an object moving through space was measured as 16 feet per minute squared. What is this in meter per second squared? Round answer to 3 decimal places. All right, this is the physics question. And then if you're curious what the acceleration is, then I'll let you Google it. Right, it's essentially the rate of speeding to show you that your speed of motion is increased by 16 feet per minute in each minute. But that's not the main focus we have here, because what we should actually do is to convert the unit to the desired final unit. That's all we need to do. Right. So we have a fraction of unit given, then we have to turn that into the desired fraction, which is meter per second squared. So first of all, we can recall that 1 meter equals to 3.28 feet. That was given, so we can just, that was given from example 8, so we can just borrow it. Then also recall that when 1 minute equals to 60 seconds, we should all know that unit conversion factor. That's another common factor. 60 seconds for 1 minute. All right. All the given units are ready, so let's do this. All right, 16 feet per minute squared. Okay, we apply the fraction method again, and then note that we're not just multiplying the original info with new fraction for nothing. We're doing this. We're doing this with a good reason. We're turning the given units into the desired units at the end. So we now borrow that statement and turn that into 1 meter over 3.28 feet. So feet units are canceled, are factored out, and the meter unit remains. Good. Next, we turn minutes into seconds. And then be careful, this is when you should square that fraction again. Because we have a minute squared given. And I'll tell you what, that is divided out with the minute unit. So eventually you'll get the info as 16 over 3.28 times 60 squared. And the unit set will be meter per second squared. So plug the fraction to your calculator, and then you will get the final answer, which is 0.00136. If you round out the number, you get 0.00136. And we need to round answers to 3 decimal places. All right, so this is how you think about the fraction method and unit conversion until you get the desired unit with the right dimension. And that's it for today. All right, make sure you practice some problems, and then I'll see you around.